This is Algebra 2, Lesson 25, homework help. So we've got a couple of word problems, and then we have simplifying radicals and simplifying scientific numbers. All right, so the first problem I'm going to work, I'm on page 119, is number 3. There were 5 times as many boys as girls at the party. That means there were more boys than girls. In fact, the number of boys was 5 times the number of girls. So boys was 5 times the number of girls. That's when your number straddles the words. Okay? Also, the number of boys was 100 less. So boys was 100 less than 15 times the number of girls. But I'm going to need my calculator just a minute. All right. I think that's all the words. How many boys and girls came to the party? All right. So for boys, I'm going to substitute 5 girls. So we end up with 5 times the number of girls is 15 times the number of girls minus 100. I'll subtract 15 times the number of girls on both sides. We have negative 10. Girls is negative 100. When I divide both sides by negative 10, the number of girls is 10. If the number of girls is 10, then we have 50 boys. 5 times that. Which makes sense because that would be 150 minus 100 is 50. All right, so it works both ways. That's number 3. Number 5. The machine broke open and quarters and half dollars fell to the floor. My whatever it is, grimaced, but still retrieved them because there were 200 coins. All right, so there were quarters plus half dollars, and there were 200 of them. A quarter's worth 25 cents, half dollar, 50 cents. And their value was $75. So 50 cents, no, a quarter's worth 25 cents. 25 cents times the number of quarters I have, plus 50 cents times the number of half dollars I have $75. I'd have to write it with the cents, because then I can eliminate the decimal and I'm going to go ahead and use substitution. So I'm going to take this one, solve it for quarters. Quarters equals 200 minus half dollars. So for quarters, that's what I'm going to substitute in. So we have 25 times 200 minus the half dollars plus 50 half dollars is 7,500. Distributing the 25, I should have known that was 5,000. 5,000 minus 25H plus 50H is 7,500. Subtracting the 5,000 from both sides and combining my like variables, I have 25H is 2,500. So I have 100 half dollars. If I have 100 half dollars, then I have 100 quarters. All right, 100 half dollars is worth $50. And 100 quarters is worth $25. And that does equal the $75 that I have. All right, 13 through 15. Simplifying radicals. All right, it's 2 square root of 3 times 3 square root of 6. 2 square root of 3 times 3 square root of 6 times 5 square root of 12. All right, the first question I asked myself is, can I simplify any of the radicals? The only one I can simplify is the 12 because it is 4 times 3. All right, so the 12 is 4 times 3. So I can unsquare the 4 and it becomes a 2. So this becomes 2 square root of 3 times 3 square root of 6 times 5 times 2. That's the 4 unsquared. The 3 stays under the radical. Okay? Now you multiply outside the radical and you multiply under the radicals. All right? So we'll do outside. So this is going to be 10. 10 times 6 is 60. All these terms are multiplied. I'm going to multiply the square root of 3 times the square root of 3 because any radical times itself is just the number under the radical as long as it's a square root. All right, so square root of 3 times square root of 3 is 3 times square root 6. So that's 180 square root 6. All right, look at 14. Number 14 is 6 square root of 18 plus 5 square root of 8 minus 3 square root of 50. All right. I asked myself, are there any perfect squares, any radicals that I can simplify? And I can simplify all of them. I can simplify 18, 8, and 50. Because 18 is 9 times 2. 9 is a perfect square. When I unsquare that, it becomes 3. So it's 6 times 3 times square root of 2. All right, that's that first term. I can unsquare a 4 from the 8 because 8 is 4 times 2. So that becomes, when I unsquare it, a 2. So it's 5 times 2 times square root of 2 is left under the radical. 50 is 25 times 2. I can unsquare the 25 and it becomes a 5. So it's minus 3 times 5 times square root 2. So we have all like radicals. So once I multiply their coefficients, then I can combine their coefficients. All right, so we have 18 square root 2 plus 10 square root 2 minus 15 square root 2. All right, so we have 18 plus 10, that's 28. 28 minus 15 is 13. So the answer is 13 square root 2. Right, number 15. Two square root of 5. 2 square root of 5 times 3 square root of 15. 3 square root of 15 minus 2 square root of 5. Minus 2 square root of 5. All right, I can't simplify square root of 5. I can't simplify square root of 15 because it's 5 times 3, and neither one of those is a perfect square. So I'm going to distribute. I distribute outside. And I multiply outside the radical, I multiply under the radical. So 2 times 3 is 6. Under the radical is 5 times 15, which is 75, minus, multiply outside, that's 4. 2 times 2 is 4. Square root of 5 times square root of 5 is 5. All right, this is a perfect square. Well, not that is a perfect square. There is a perfect square that is a multiple or a factor of 75, and that's 25 times 3. I can unsquare the 25, and it becomes 5. So this is 6 times 5 times square root of 3 minus 20. I'm going to put this in proper order because we go rational, irrational, and imaginary. So my negative 20 is going to go out front, and then we're going to put 30 square root of 3 because 6 times 5 is 30. All right, now we have scientific. This is number 18. 38,000 times 10 cubed. I'm going to erase this so I can go up a little higher. 38,000 times 10 cubed. 300 times 10 to the negative 4th. 300 times 10 to the negative 4th, all over 0.00019. make sure I get my zeros right, times 10 to the negative 5. Okay, the first step is I'm going to put every term in proper scientific form, which means 1 digit to the left of the decimal place. All right, so right here's the decimal. So I'm gonna move it 1, 2, 3, 4 to the left. So that's positive. All right, because I look at where I need to move it back to. Remember, left is positive, right is negative. All right, so this first term is 3.8 times 10. Right now it's cubed, so I'm adding the 4 to it. I'm just double checking that I wrote that right. So it's 10 to the 7th, because 3 plus 4 is 7. All right, this is 300. I move the decimal 1, 2 to the left, so that's positive. All right, so it's 3.0 times 10. Now I add negative 4 and positive 2, and that's negative 2. All over. Now I'm going to move this one to the right, so it's going to be negative, okay? So it's 1, 2, 3, 4, so I'm subtracting 4. So it's going to be 1.9 times 10. Negative 5 and negative 4 is negative 9. Now I can break them apart. I can do my constants and my 10 to the exponent, to the power. All right, so it'd be 3.8 times 3.0 over 1.9 times 10 to the 7th times 10 to the negative 2 over 10 to the negative 9th. I'm going to multiply and divide that. All right, so it's 3.8 times 3.0. That's 0, 0. Remember how to multiply with decimals. All right, that's 24, that's 9, 10, 11. So that's 1140 with 2 decimal places. Now I'm going to divide 1140 divided by 1.9. I'll do it right here. But remember, I moved the decimal place 1 and 1, so that my decimal place goes here. All right, so 19 goes into 111. Let's try 6. That's 54. That's 11. So it is exactly 6. So this is 6.0 times. All right, I'm going to do this first. I'm going to do the numerator, leave the denominator the same. So I'll do multiplication is addition. So 7 and negative 2 is 5. Then I'll do the division is subtraction. So it's 5 minus negative 9, which is 5 plus 9, and that's to the 14th.